You want to earn a spot in the University of Zimbabwe's prestigious BSc Honors Mining and Geological Engineering program. It's a demanding path that puts you right on the edge of the country's resource sector. But before you can step foot on the Mount Pleasant campus for the August intake, you have to clear a strict barrier, a mandatory high-pressure psychometric screening test. Preparing for this assessment with generic aptitude guides will leave you exposed. The HMIE program requires a highly technical way of thinking, and the screening is tailored to find that specific mindset. The assessors aren't looking to see who has memorized the most textbook definitions. They design these tests to expose who can process information, identify patterns, and solve problems under severe time pressure. By focusing your preparation strictly on spatial, mechanical, and numerical reasoning tactics, you can bypass the noise, prove your capability, and secure your interview slot. Standard university aptitude tests often prioritize verbal comprehension or abstract vocabulary. Engineering assessments strip most of that away to focus strictly on physical and logical systems. This pie chart shows how you should allocate your study time. Notice that 40% goes to mechanical and spatial reasoning, 30% to numerical, 20% to reviewing physics concepts, and only 10% to abstract or verbal reasoning. This breakdown mirrors the exact cognitive load you will face in the field. A mining engineer doesn't write essays to stabilize a rock face. They assess structural loads, calculate extraction rates, and visualize three-dimensional space. The test evaluates your potential by seeing how well you grasp core physical principles. The questions act as a proxy for how intuitively you understand the physical world. Reading comprehension won't help you extract ore. You have to train your brain to quickly visualize and manipulate complex, three-dimensional physical systems. Step 1 is mastering spatial reasoning. This is your cognitive ability to mentally manipulate, rotate, and assemble objects in 3 dimensions without physically touching them. A classic example is predicting how a flat, 2-dimensional geometric net folds up to create a solid 3-dimensional shape. Step 2 is mechanical reasoning, which tests your understanding of how distinct physical parts, like levers, pulleys, and gears, interact within a closed system. When you practice these questions, break them down sequentially. Ask yourself exactly what happens when the first component moves. If gear A turns clockwise, trace that motion step by step to see how it forces gear C to react. You already have the tools to solve these puzzles. The visual logic in these tests relies heavily on the foundational A-level physics concepts you studied in secondary school, specifically kinematics and forces. The basic laws of motion and leverage dictate the correct answers. Apply those exact rules to the mechanical drawings in front of you. Acing this section proves to the admissions panel that you possess the intuitive grasp of applied physics necessary to safely manage massive mining operations. Step 3 is numerical reasoning. You are not being tested on complex arithmetic. The assessors are measuring your ability to rapidly identify patterns in data. This graphic shows a classic number sequence. The trick is to find the hidden rule connecting the data points. Here, the hidden rule is to multiply the previous number by 3 to get the next one. Avoid the ego trap of trying to do all the calculations in your head. Have rough paper ready. Write down your intermediate steps and know how to use your calculator efficiently. Efficiency is critical because of the severe time limits. Some psychometric tests demand you answer up to 55 questions in a maximum of 14 minutes. That leaves you with an average of roughly 15 seconds per question. Hesitating on a single problem will ruin your score. To counter this, use the skip and return rule. Look at a question, and if the path to the answer isn't completely obvious within 10 seconds, leave it and move immediately to the next one. These assessments are specifically designed so that most people do not finish them. Completing the easier questions first ensures you capture all the guaranteed points available. Leaving a difficult question blank is not a failure. It is a strategic engineering decision to maximize your total output by balancing speed and accuracy. Step 4 is biological. Processing rapid-fire information under extreme pressure takes a massive physical and mental toll on your brain. To optimize your brain chemistry before you sit down, follow the standard advice from psychometricians. Get a complete, regular night of sleep beforehand and drink plenty of water. Avoid heavy, fatty foods in the days leading up to the exam, as these will make you feel sluggish. On the morning of your assessment, Eat a light, energy-rich breakfast like porridge and a banana. Your biological preparation is the final, non-negotiable variable in the equation. A tired mind simply cannot engineer solutions. Let's review your blueprint for the HMIE assessment. Prioritize spatial and mechanical logic, apply your A-level physics rules, and ruthlessly enforce the 15-second skip rule. Your next step is to put this into practice immediately. Find a free mechanical reasoning test online today. Open the test, set a strict 15-minute timer on your phone, and simulate the pressure environment you will face at the university. If you practice these questions under strict time conditions, your confidence will grow. You are ready to walk into that testing center and show the University of Zimbabwe that you possess the mind of an engineer.